Hey, we're going to go ahead and rewrite some equations to solve for a variable. So we're not solving for, x equals 2 or a equals 2, but we're going to rewrite some equations and rewrite some formulas. So we know the area equation is sometimes written as base times height, but maybe you don't want to solve for area for A. Like maybe you want to solve for B for the base. So how do you get the base by itself? Well, it says times h, so instead, divide by h on both sides. H over h is 1, and b times 1 is just b, so that cancels out. And now I've solved for the base. The base is the area divided by the height. Cool, so you can do different things like that. On the right side, if you want to solve for length, you could do that. If you want to solve for width, you could do that. Let's solve for the w. Well, that means I need to get rid of times L. So I will divide L. L divided by L is 1. 1 times W is just W. So that's like the L's canceling out. So the width is the area divided by the length. There you go. So we're like rewriting the formulas there. In these, we're going to go ahead and solve for y. A benefit of doing this is we can put into y equals mx plus b form, called slope-intercept form. Might be easier to graph or find what the slope is. Like I don't know what the slope of these equations are right now, but if I solve for y, I will know what the slope is. So I'm going to go ahead and get rid of the x's. 8x minus 8x is no x's. So 2y is equal to 10 minus 8x. And to get y by itself, I'm going to divide by 2. I got to divide everything by 2. 2 divided by 2 is 1. 1 times y is y, so that's just canceling out. What is 10 divided by 2? That is 5. What's negative 8 divided by 2? That's negative 4. And that had my x. Cool, this is way more helpful to graph, way more helpful to figure out the slope. Now I know the slope is negative 4. We did that last chapter. I know the y-intercept would be at 0, 5, my starting point. So if I solve for y, it's going to make it a lot more helpful to see some key points and key features of the graph. In order to solve for y, I'm going to go ahead and get rid of the x's. 6x minus 6x, that's 0. That cancels out. I got negative 2y equal to 22 minus the 6x. I cannot combine like terms there. They are not like terms. I will divide by negative 2. And I'll choose to divide everything by negative 2 here instead of doing the one big fraction like I did last time. Just proving to you there are different ways to do things. Y equals 22 divided by 2 is 11. Don't forget that there is a negative there. 6 divided by 2 is 3. We have a negative divided by a negative. That will cancel out and turn positive. So I have positive 3x. Cool, that tells me that 3 would be my slope, negative 11 would be my y-intercept. Again, they're not asking for that on the problem, but when I solve for a different variable, it might help make things more recognizable, easier to find, beneficial, things like that. Cool, let's keep solving for y. Notice I'm just getting rid of my x's, getting rid of my x's. All right, I bring down 3y. These cannot combine on the right side because that's a number, and that is some variables. So now I'll go ahead and divide by 3. Again, do you want to divide everything by 3? Do you want to divide each piece by 3? Again, just make sure it's balanced out. 3 divided by 3 is 1. 1 times y is just y, so that's why that's canceling out. Negative 12 divided by 3 is negative 4. And negative 7 divided by 3 is a decimal, so I'm just going to go ahead and leave it as negative 7 over 3x. I have solved for y. Awesome. On the right side, we are solving for y. Ooh, but y is up front, so we're going to get rid of the negative 3x's by adding 3x's. So I'm just moving the x's to the other side, trying to isolate the y's, get the y's by themselves. I can't combine 20 and 3x, so I just write 20 plus 3x. Divide by 5. You can divide everything by 5. You can divide each piece by 5. 5 divided by 5 is 1. 1 times y is just y, so I got y by itself. 20 over 5 is 4. 3 over 5 is a decimal, so I'm just going to go ahead and leave it as 3 over 5 with the x. And now I have solved for y. right, let's finish up with some challenge problems. Let's solve for c in the famous E equals mc squared. Keep in mind, this equation is E equals m times c squared. How do I solve for c? I get rid of the other things on that side. It says times m, so I'm simply going to divide by m and divide by m. That will cancel out, and I get E over m is equal to c squared. Do you know how to get rid of a squared? Well, you can go ahead and square root. So the square and the square root will cancel out, and you will get c by itself. And so if I was solving for c instead of E equals, the formula would have looked a little bit different. So maybe the famous mathematician there, I think that was Einstein, maybe if his name was Carlos, maybe we would have solved for c instead, and that would be the famous formula that we know. All right, let's go ahead and finish up with y equals mx plus b, and let's solve for m. M is kind of attached to the x, so we'll get there in a second. Let's go ahead and get rid of that plus b that is sitting there on the side. So let's go ahead and minus the b. How do you do y minus b? I don't know. I don't know what those numbers are, so I'm just going to write y minus b. Bring down the mx, which is m times x. So how do I get m by itself? I divide by x to cancel out the times by x, and I divide by x over there. How do I divide y minus b divided by x? I have no idea since I don't have those numbers, so I am just done. The formula, if I would solve for slope, is y minus b over x. There you go. There's a bunch of practice on solving for a variable when you don't necessarily have numbers, or when you have more than one variable, multiple variables, and you maybe just want to pick a different variable to solve, to isolate, or to maybe make a new y equals equation so you could find the slope and intercept and things like that. And there you are. That's the end. Peace.